Hello guys, welcome back to my channel. I hope you guys are doing well. So if you're new to my channel, my name is Arnabi. I'm working in Amazon as a SD, and as you know that I have already created a playlist for DSA, and I have started all the basic DSA, all the mathematics related DSA. Now I am moving to a new playlist, and this playlist I will be talking about the binary search algorithm. So I will start today with the basic binary search problem, and from now on I will be keep on posting all the problems which are applications of binary search and where we can solve any question with the binary search approach. So without wasting any time, let's start. Okay, so first we need to know what is binary search, when we do need it, and when we can apply these things. So let's take some example. For example, what is binary search? So our first question will be what is binary search? Just a second. Let me, yeah. So what is binary search? So this is basically searching. And what is difference between the searching and binary search, like normal search and binary search? So for example, we have one array like this. Suppose we have 5 2 3 7 1, and we need to find, suppose our target element is 3, we need to find 3, and that is here. How we can do? We can scan for all the elements in the array. Like first we will come to 5, that is not 3, then we will come to 2, that is also not 3, we will come to the third element and that is 3, and we can say okay, we found it. So this is a complete normal search. But what is a binary search and when we can use it? So for example, we have this array like this: 2 3 1 2 3 5 7. So that array is sorted, and this is the time whenever one array is sorted we can apply binary search. How we will apply? So I will just give you a simple logic. For example, you need to find one word in dictionary, maybe a word rat. So what we generally do, so we also in general in our life apply binary search. How and what? So suppose you need this word rat, you need to find this word. So what we will do, you have this dictionary. So what you will do, you will just open one page randomly, and then suppose that page has all the words starting with S. Then you can think that okay, so S comes after R, we need to search something in the left side, and we will again find another page which is in the left side of our previously open, and like this we will try to find. So this is something we do generally. Same logic, same thing we will do in a binary search. How? So let me tell you. So what we will do, let's take an example. We have 1 2 3 7 9 10 15. Okay, and we need to find this element 3. Okay, what we can do, just like a dictionary, we can open one page, but instead of opening random page we can find the middle. Okay, so middle will be something like this, or let me just add another element, it will be easy for us to find the exact middle. 9. Why we are coming to middle? Because it's the chances of coming to middle are more. So even though we want to find 3, we don't know how many numbers are there, what are the range. For example, here the numbers are in between 1 to 16, but we don't have any idea. So let's just go to middle. So instead of coming here, like if we choose this number and 3 is here, so the range is still a long. And suppose we were coming to the range of the right side is still long, but as we are at middle, and in our middle element it's not a hit, so they are at equal amount of range in both side. Okay, so I have come here, and this 9 is actually greater than 3. So 9 is greater than 3. Then what we can conclude? One thing is clear, every element at right of the 9 are obviously going to greater than 3. So there is no point of finding one this element in right side of 9. So we will close our search in between this left zone. Then we will again come to the middle, that is 3. And yeah, this is a hit. We will return, yeah, we have found 3 and true. Let me take another example where we are doing a lot of search. For example, let's start with like this: 56, 77, 81, 100. Yeah, and we have 1 2 3 4 5 6 7 8 elements, and this will be our middle, and we need to find 56, this element. Okay, so we will come here and we will find 49 is less than 56, so all the element in left will be obviously less, so our search space will be here. Again the middle element is 77, that is greater, so our search space will be reduced to only this number, and this is a hit. So see, we just have only three uh, search space. First we had the whole array, then we decrease it to the right side of the 49, and then again we decrease this to the right of 49 and left of 77. So we are not actually scanning the order of n. We are not doing this. We are not scanning the whole array. What we are doing, at every step we are dividing it half. So at first we have an array of size 8. In the next step we had an array of size 4, and again at the next step we have it's only 56, so array of size 1, or we can say like 2, because we had this 77 as well. But anyway, we are decreasing like this, so our search space is actually keep on decreasing. First it has 22 to 100, 8 elements, then 49, 56 to 100, 4 elements, and then only one element, 56. So this way it is decreasing, or we can say it's actually log of n time. So we had 8 elements and we had only this 3 pass, so it's log of n. So this is actually our binary search, where instead of order of n we can search one element in log of n time. And now there are some questions like, what is the necessary condition for binary search? Obviously the array should be sorted, otherwise we won't able to apply binary search. Now if array is not sorted, or we have a given random array, then should we go for the binary search? Option is no. For random arrays always we should go for the linear search, because we need to sort the array and then we can apply binary search, and sorting we know it will take n of log n, and then a binary search will be log n. So this is more than actual log n, actual order of n time. So whenever one array is sorted, then only we can apply the binary search. Now without wasting much time, I will quickly show you the logic, and then I will show you the code. So what is the logic? So what we have want to do, first we will take a start element, because we are only doing as a range. So at first our start will be 0. We will start with the 0th index and end will be n minus 1. So n is the size of the array. And we will find the mid element. So mid element is what? Start plus n by 2. It's always like this. We will find the mid element. So in case there are even number of elements, for example there are 8 elements, then our mid value will come like this. So 0 plus 7 by 2, it will give 3. So it's actually the third element if we are talking about 0th index. So 0, first, second, third element will be our mid. And if it has the odd number of element, then mid, finding the mid is easy. I'm saying this because let's suppose this element. So here we have odd number of elements, that's why mid is 3. But suppose we have 1, 2, 3, 5, then mid will be 2, because these two are mid candidate and we are taking the first element. So this is how things will differ. Now next we will just run one while loop, because we are just doing the same thing again and again. And here we will give the condition start is less than equals n. Why less than equals? So there can be one candidate, and that time start and end value will be same. Okay, we will here we will actually find the mid value, start plus n by 2, because at every section we will be checking the mid value. And we have three condition. One, if array of mid equal our target. This is the first condition. If yes, we will return true. Or there can be two conditions. What are they? There can be another condition like this: array of mid is greater than the target. That meaning all the elements on the right of the mid are greater, and we need to reduce our search space. What we will do? We will simply make n equals mid minus 1, because anyway start is the same, and we can keep the start pointer there only, and mid is also not our candidate, and every elements of the right of the mid are not our candidate. So our search space will be start to mid minus 1. Else, so only another condition is left now. We have already checked for equality, greater, and the last condition is less than. So no need to check that condition. We can simply write an else, and we can, that case we will make start equals mid plus 1. Why? Because left side of the mid is of no use. So we will make our search space the whole right side. So this is the application of binary search, or sorry, this is the binary search algorithm. Now I will quickly go to the code, and I will show you both the Java and C++ code, and as well as iterative and recursive solution. So without wasting any time, let's go there. So here I have already pasted the solution in the Leetcode, and this link I will be giving you in the description. So first, the time complexity is obviously log n, and space we are not using extra space, so it's order of n in case of a iterative solution. For the recursive solution, we need that stack space, but for the iterative solution we are not using any extra space, so iterative solution is better. What we are doing, we are taking start and end value, then just running the while loop and calculating the mid, and there are three conditions. If mid is equals to target, then we will return the mid. So it's a Leetcode question. I will give you the link of the question as well. Here they just want the index at which the target is present, and if not present, then we will return -1. So if there is a hit, we will return mid, otherwise we will change the search space. The Java and C++ code, they are same, only this line have a change, because finding the length of the array there are some difference. And I have also mentioned the recursive solution. So here what we are doing, we are just passing the start and an end. So at any point of time, if start is greater than end, that means that element is not present. So for that I can show you a quick dry run. So suppose we have this One, two, three. Just a second. Let me just have this pen. Yeah. Suppose we have this 157. Just giving a small example. Okay, and we need to find two. So first made is 5. Here we are not getting any thing. We will come here, and one is greater than, sorry, one is less than 2. So we will try to find at its left. So at this step, our end is actually 0, and start will become, it is 0 plus 1. So 1. So at this step, start is greater than 0, and this is the case where we are failing. So in this case, we will simply return -1. Otherwise, we will calculate the value of mid. If we found it, then return. Otherwise, the same way, we will just call with start mid -1 and mid plus 1 end, depending on the which condition it is falling. So this is very easy binary search. I will come back with many more binary search question applications. So if you don't know binary search, I will suggest you can go and check and solve this question. It's not that much tough, and later I will come with some easy, medium and hard level question which are actually applications of binary search. And other than that, if you want to connect with me, you can connect in my Telegram and LinkedIn. All the links are there. If you want to have a 1:1 call with me, then you can book a call in Topman. Thank you. Bye.